Hello, everyone, and welcome to Handmade Hero Lighting Edition. We are going to today take a look at the last thing that I think is a quality issue with the lighting. We just kind of have a we've got some pretty good stuff here. It looks really good. The lighting, I think, is high quality, but when we look at just right around single bright light sources, it's just not a very high quality result. It's very like squarey and also a little bit irregular. And this is the best case scenario when we've cranked up sort of the bounce level. So this is this is a number that we could easily do on the GPU. Right now we're on CPU side only, so it's a little bit slower frame rate than it should be if we were going to try and roll out something like this exactly. But even if we want to talk about just CPU side, what we can do right now, it's actually quite good. If we drop this down to like 8 instead of 16 samples, rays per texel there, you can see that we get a really smooth frame rate here, and it actually looks quite good everywhere else. So just those small moving light sources, right? They're just not good enough in my opinion, and they definitely have that like made with Unity Personal Learning Edition kind of vibe to them, right? And it would be nice, because the idea here is to do some reasonable quality engine programming. It would be nice if we could get rid of that, because it makes the rest of the lighting not look as good, right? It's like a quality, it's like a polished quality step down. You know what I'm saying? And so I guess I would say what we want here, I think, is to look at ways to mitigate that. And we looked at some ways of trying to improve it last time, and they really weren't sufficient, and I don't think they're going to work long term. So I thought about it over the week, as I often do, kind of just like in the back of my head while I'm doing regular work. Sometimes I think about Handmade Hero stuff because it just pops in. And what I was thinking is that I originally said maybe you probably remember me actually literally saying this. I was like, what if we, instead of, everything right now, light probes cast rays and they hit things. In this case, there's a light hovering above the hero's head that we were using for testing right now. And the rays from the various light probes, they hit that thing, and that's how they know that there's light that they should represent. And that works quite nice for diffuse like gather, right? They in all of these scenarios, when you look at where the light's getting gathered everywhere else, this actually looks quite good, right? And the reason that it looks quite good is because of the exact inverse of what normally happens with forward lighting, like the kind you would see if you just use light source with shadow maps. What you see is the lighting quality looks very high, looks very convincing and good in areas where there's a lot of light coming from a lot of different directions. That's what makes indirect, like this global illumination, it's what it does really well. What it doesn't do very well is that part where you just have the direct light source shining right on a particular thing. And that is this scenario in a nutshell, right? What we've got here is a small, fast-moving light source, and it just doesn't produce the same kind of like nice results that you would expect. There's also a fair bit of flicker that comes from these lights because, again, since it is a small light and it's in a wide area and there's not much other light around, right? You get more of that sampling noise. We could try to take that out with better sampling, more focused sampling, various things. But to me, that is actually not a problem. So to me, that you can just chalk up to effectively like, oh, that's just, the lights are a little flickery, right? It looks atmospheric almost. So to me, I'm not really concerned. If that was the only problem we were looking at, I'd call it done. I'm fine with that as an artistic thing. I'm not worried about that at all. It does not ruin the look of the game at all to me. What ruins the look of the game for me is this bit, right? That is just not quite good enough to me. It just looks very square and weird, and more importantly, in a way that's not actually the case anywhere else. So, when you look at these kind of larger, more diffuse lights over here, and, elsewhere in the game, you just don't get, that's not happening, right? Everything else looks softer, it looks nicer, it looks cleaner, and then you get into, to here, and it just looks really ugly and square. So that's really the thing that concerns me, and so what I said last time was, well, maybe one thing we could do is we could try rasterizing light sources forward. Instead of strictly, being, instead of exclusively having light probes cast rays backwards and hit light sources and sample them, what if we did a forward pass where each light source would walk through the squares it overlapped, and it would write its lighting directly in. So it wouldn't have to actually, it wouldn't need to do that part of the process where it, we wouldn't need to worry about the fact that it's hard to sample a small light source. Because that's basically what's going on here. It's this light is missing entirely, none of, we're not getting any light contribution here, not because this light wouldn't necessarily contribute here, but just because this light source itself is probably never getting hit by any of the rays, just accidentally, right? So even though that light source, and I can make that a little bit more explicit, if I go in here and we, turn on the spatial grid drawing, and then wait for it to, the compiler to finish, and there you go. We should be able to turn on drawing of light sources and see them. You know what I'm saying? And honestly, I guess I don't know. I'm not sure, exactly what we're drawing here. So I think that's actually the emitter, right? That light, I think, is actually the emitter. It's quite low to the ground. That's probably another reason why these things are not seeing it easily. If it was up higher, that might not be a problem. I wonder what it would look like up higher. This is not really what I was expecting to see. But I guess that's where we placed it. Maybe we should fix that first, because that's also maybe a little misleading, since I thought it was a little higher up. But either way, still, I think we're going to have the same problem. It's just, that's interesting. I wonder if that's why it's a little bit more exaggerated than the other light sources. Maybe it is. I don't know. Let's find out. So in here, when we add the light, this is us adding the light here. And yeah, I guess, normally you would probably expect to have seen something elevating it off the ground like here. And we didn't. So when the player got added, it didn't actually do that. So that's interesting. So now it should be a little higher up, I think. Yeah, there we go. It's on the hero's head, right? And we could put it even maybe a little higher than that. So that is a bit interesting. I guess that was somewhat surprising. I wasn't necessarily expecting that. That's interesting. So if we now look, actually, you can see that the fact that it was lower to the ground was actually a pretty big deal in terms of how square the lighting was, which is interesting. And so I guess maybe that was a bit misleading. I didn't quite realize that we had, I I didn't quite realize that that was contributing as much as it was. It actually looks a lot better in this way. Maybe, you know, if that was it, you wouldn't really be that concerned. So, gosh, I don't know. Does that mean we should just move on? Like, I would be fine developing the game that way, and then maybe I still do a little bit of fixing at the end, but that's surprisingly good, I guess is what I would say, compared to what we thought we had, which was not as good. Yeah, I don't really know what to make of that. I guess that's just because when it's sitting on the ground like that, you have a lot of there's quite a difference in how it's going to be hit. It's a bit strange, but you know, I guess I could believe that. All right, let's. Okay. Well. Huh. I don't know. Yeah. All right. So do we just say that's good enough for now then? I don't know. It's still a bit square, right? I mean, it's not fabulous, right? But it's a lot better than it was. So, Well, that's a tough one. I would classify that as a tough one, and I'm not sure what to make of it. Maybe we just. Gosh. I mean, maybe we just call that good enough for now. I mean, I feel like that's more than good enough to do the rest of the game with, and then we could do before shipping maybe some more cleanup of it. I added a light to the glove here. You still get a fair bit of lag on the glove, but well, yeah, and it still is a bit square, right? I mean, it's not great. So, you know, there is that. So, I guess I'm a little bit torn. I don't know now. Should I pursue this a little bit further, or is that good enough? And yeah, there's no tone mapping on right now. Tone mapping, I think in theory when we add tone mapping, I think it will actually improve the perception of how the lighting is, I think. I don't know that that's true, but it might. So that might give us a little more. I don't know that it will fundamentally fix the squariness. It might. I don't know. I mean, we could try it. It's certainly not that difficult to try. But yeah, wow, okay. Well, I'm just not sure that wasn't what I was expecting to find. I do wonder, so if the glove floats above the ground a little bit, if we added the light, if we pushed the light of the glove up, what does that do to it? Because I don't know what that does either, so I'm going to take a look. But yeah, gosh, I don't know. I really couldn't tell you. That's really a tough call. I guess I would say, like, I don't know. It's still an open question to me, like, if some of that squareness can be repaired. And, you know, I don't know. All right, I guess here's what I'll say. Since I don't really know, maybe what we should do is actually go ahead and do the tone mapping. And put in some semblance of like what we would expect to have happen as sort of like a final rendering pass, like something that's going to take and produce an output. Yeah, I mean, that seems like maybe the best idea is to just go ahead and do that. I mean, the reason I say that is just because we know we need to probably do that. We know that tone mapping is not a huge deal and it will improve the look of the game, so we probably would want to do it. And I guess I can't think of a reason not to do that. So maybe we just do that. And I guess I don't know which tone mapping I want to do. I don't, not being someone who really does this part of stuff for a living, there's a fair number of different ways that we could use our outputs on tone mapping. So anyway, the way you typically do tone mapping is it looks like this. I mean, it always looks like this. Basically, what you're doing is you take some kind of an incoming light level, and this is the ACES, which is like this kind of standardized curve. I don't think I've ever used this one, but I know about it, so effectively what this is doing is it produces a curve that approximates some kind of a film, like literally like a piece of film, how it will respond to incoming light. And it's just a piecewise polynomial. In this case, it's a rational. It is a rational, not irrational. It is a rational. And if we drop this into like Desmos or something, you can see what it looks like. I mean, that blog entry probably had that as well. But like here, so if we graph like y equals x with this nonsense here, and then we put in these numbers in response to it. In fact, we could leave them as sliders so that we can play with them later as well. So if we take a look at A, B, C, D, it said that A was 2.51 and that B is 0.03 and 2.43 for C, and 0.59 for, where is E? What happened to E? Oh, you know what? It thinks E is E. It probably thinks that's Euler's number, and I can understand that. Am I allowed to say, in this case, E is not E? I don't know if I am or not. Well, you know what? Let's call it Z. How do I add a slider for something in this program? I don't know Desmos very well. There, we'll do it that way. At least it works. So Z, which is E in this case, I just wanted to get a slider for it. Okay, so now we've got our A, B, C, D, and Z, which is actually E in this. And so X comes in, and it's a brightness level, and here is the parameters on it. Here's the curve that they drew, but we've got our own one here, I guess. So, here's what this looks like. And you can kind of see, like, in their drawing of this, it's a little exaggerated at that point. They're sort of showing a flatter version of it, perhaps, than are we. They go out to 10. I don't know. Ours doesn't look quite like theirs looks. Did I put something in incorrectly? 251 003 243 059 014, and it's ax plus b over x times c times x plus z. I don't know. Looks like it's right, but does, am I wrong? They're going from 1 to, oh, I see why. This is a log scale. So in order to get ours to look like theirs, we would have to make this be a log axis. I don't actually know if this program does this. It might. Not seeing it though. So I don't know. We might not quite be able to get it to match, but that's just because, right, it's a log scale, so you would expect it to be. Yeah, I don't really see any way we can do that. So I don't think we can get a log scale, but point being, they've elongated this part down here, right? This is plotted on a log scale. So for them, right, they're basically looking at one that goes from 0 to 10, like so. But they've stretched it so that, like, the part from here to here is, like, as long as the part from here to here, right? They've kind of log stepped it, right? Yeah. Does anyone know? Sorry, I guess I'll just ask. Does anyone know if you can get a log scale? I don't know if you can. I don't see it. That's what I was looking for. But I mean, it doesn't really matter because, like, if we wanted to, we could do something like... Right, maybe, I guess it's, but it's the wrong way around. So just log that, like log of the whole thing, sorry. That will not work. It almost worked. Yeah, because we want to be able to say, like, well, what would the output be if you were to plot the output? So I guess you would do yeah, like, I don't know. This won't work, I don't think, but I could be wrong about that, because that's a different way to do it, right? Log of this whole thing is not going to do it because we don't want the output plotted log. We want the input plotted log. If they had if they had done a log on y, then sure, but they didn't. So I don't know. I guess we can't quite get a match of that. But otherwise, yes, you can see what this curve is attempting to do either way. Yeah, that's what I was going to say. Like, we could do 10 to the x in there. Yeah, exactly, right? I am bad at math as well, but, like, we wanted the opposite of what that was doing. We wanted to do... Probably shouldn't have deleted that. So, you know, if we did 10 to the x, that's the opposite of log. I actually put in log, which is not what we wanted. So if I maybe do this, we can get it to simulate what would happen if you plotted on a log scale. Maybe. And then we put in our constants again, right? Copied in backwards order. Should have clicked on the add slider buttons in the opposite order, right? So, like, in theory now, yeah, like, you can see now it looks a lot more like theirs, right? It kind of goes slow, right? Slow up and over. You know what I'm saying? And you can also see here that, like, what the effect of these dials actually is, right? So you can see, like, A kind of controls, like, where we're headed, right? B is that knee, that top knee. C is the angle, like that exit angle there, right? D is the other part of that top knee, and Z is where the inflection point, like how you roll it forward, right? So like you could, just intuitively as you play with them, you can see what they affect, and you could tweak it. We don't really care about that so much. The point is just that this is sort of the kind of curve that you want for film when you're trying to do, like, what does it look like to expose film? You want something that has this sort of natural asymptotic, like going down towards black, going up towards white, that's, gradual, and in the middle is somewhat linear. That way, no matter how bright things get, they always sort of fall somewhere in your mappable range, no matter how bright it gets, right? And so more importantly, you can see that this, even though this is like an official ACS, like tone mapping curve, you can kind of see that it's very simple. Like, this is not particularly complicated. It is rational, which is not fabulous. And, I think I remember this. Oh, is this gone? That's unfortunate. All right, can we get that? This was a good article. Is that gone? No one's ever really gone. Can I get it back? Did I do that wrong? Yes. So was this the one? So this one's still rational. I could be very wrong, but I could have sworn the last time I worked on something like this, I did one that was basically, that wasn't actually rational, so it didn't have a divide, but that basically did what I wanted. And I guess I don't remember where I got it from. Maybe I worked it out myself. I don't know. It's been a long time. So anyway, the point is, a divide is somewhat expensive, but these days it's not that bad. So you might, and since you only really do it at the end, you're only going to do one of these for a pixel, right? Well, possibly more if you're doing multi-sampling, but you're not doing very many. I guess people just don't care these days, but it is true that a divide's a lot more expensive than, like, just a straight ahead multiply add. The rest of this stuff is all FMADs, which are the cheapest possible thing. But then you got this divide in here, and that's somewhat expensive. Now, I don't think it really matters because, like I said, we're not doing it that. It's not a heavy lifting kind of a thing. It's not happening like many times per pixel. So, it's probably fine. But in general, this curve, I guess let's start with this curve. Because, hey, it's well known, it's a standard, and we can tweak it pretty easily if we want to. So maybe this is where we start. Like I said, I'm a little less comfortable with it just because of the fact that I don't know that you really need a divide. I don't know that this has to be so precise as to need a rational in it, and that just feels off to me. It doesn't feel like something you would need, but I guess apparently that's how they did this. So yeah. I don't care enough to go further, I suppose. So this is just literally their curve. And, we've got our params. We have F32 defined here, right? Yeah. You can't put Fs, if I remember correctly, in the version we're using here. So it's going to look a little bit different. But otherwise it's the same. And so basically we pass in an X, which is the incoming light, and it just returns the tone mapped version of it. So that would be a basic Filmic tone map, and we literally can just drop that in, I think, when we're done. So, in here you've got lighting summation. What the heck? What is that here for? Anytime we go spelunking in this nonsense shader that we wrote, it's always a bit of an absurd. Yeah. Like what? I don't know what the heck that's supposed to be. Why is it being clamped? I don't know. We don't need the light floor anymore, I don't think, because it's not defined to be anything anyway. Right? It's just 0. So, all right. We're going to get rid of this and this, and we're going to start here. So we're just simplifying things a little bit. Is anyone calling this function? Yeah, this is just old stuff. So we've excised all of that stuff out. It's gone. What is this? Open just for the goal fund saturate. Oh, right. That would be a D. That's a D3D kind of a thing. An HLSL. So we don't want that. That's just a clamp 0, 1 is all that is. Saturate is just their term for clamping between 0 and 1. And I think we already defined our own clamp 0, 1. Right? Yeah. So we can just use the standard thing that we would do, and that will do the correct thing. It's just, it's just a nomenclature difference between GLSL and HLSL, which I assume that the code that they were talking about was HLSL there, so that's why it had a saturate in it, right? Which is totally reasonable. Okay. That's about it, I think. So here's us doing our thing, hopping around and having a party and hopping party. And so now we need to put in this tone mapping, and I don't think there's going to be a huge difference between what we see. I don't think it's going to be huge. But again, at least now this way it will be roughly correct. And you can see in here, so we've got our surface reflect. We have a fogging factor, but I can't really say why anymore because we don't use the fog. Maybe we leave that in because we want to use fog in the future. I guess. I don't know. Anyway, so we've got some other garbage here. We've got like a lerp between this and a frag emission value. And that frag emission thing is here. I don't know who actually sets the frag emission stuff. We're going to have to look at that stuff because we're going to need it later. We're probably going to want to render light sources that are emitters, right? And then when they are emitting, you can see here they would then flow through and they would do a boost basically. And this clamp 01 now, I think we just want to replace this right here with our ACES film map. So rather than just clamping between 0 and 1, we want to feed this into the tone mapper. So here's what that looks like. And, you can already see it looks a lot better, right? It looks a lot more dramatic. Being fed through the tone mapper, it's just nice, right? A lot more dramatic, a lot more stark and interesting, right? But I would say the squariness, right, still totally there. It doesn't really help. If anything, it sort of exacerbates that. And so while everything else looks really good, like any area that has a lot of light looks 10 times better. Areas of low light have that squariness problem. But yeah, I mean, it's a nice response curve. It looks a lot better. There's no question about that, right? It definitely looks a lot better. So, yeah, I guess I would say... I mean, based on that, I'd say I might still want to do the light rasterization. Because, yeah, this looks good. The tone mapping is definitely an improvement. We would want to keep that. But the squariness persists. It doesn't really help with the squariness very much. And I guess we also don't know. So if I switch these to spheres, I don't know what that does, if anything. But basically no change. The squariness kind of remains. They get dimmer because they're smaller, right? But not really a dramatic difference, I wouldn't say. Yeah. So, gosh, I think that kind of argues for still doing the rasterization step. I think that argues for doing the rasterization step. Because obviously we could change the way we're doing interpolation and maybe that would help. It's true. But I also don't know that I feel like we probably have a lot of mileage we could get out of just more accurate light source placement. Into the voxel. So I guess I don't know what to do next. My guess is we should just try rasterization, direct rasterization. I think that feels like what you would want. Dr. Zool, the light probe positions are already jittered. If you would like to see what I mean by that, here is one of the ray samples. This is just the first one taken. And you can see that it's already jittered, right? So, you know. So, yeah, I don't have a lot else to say about that. I guess I'm not really sure what I think I should do for the next step here. What I will say is that the lighting looks awesome. I'm very happy with it. So I really have no complaints about it, and I think you could ship a game this way. I just think that squariness, I think I can probably fix it if I do direct rasterization of the light sources, and because the lighting looks so good, and, you know, it kind of brings it down, like when you're out here, like, for example, and you get that squariness, it just kind of brings the quality down. I think I should probably just try it, because if it did fix it, then that would be like the lighting would basically be perfect. I mean, everywhere else, the lighting is spectacular. To the point where stuff now just looks so freaking good. It just looks so damn good that I feel like if it's a shame to let one thing bring it down like that, and it's just because I think we don't have a good way of handling when you're close to a light source, so you get that drastic, almost a step function when all the rays then miss, or a large number of rays miss, and you don't so you don't have a proper interpolant. You end up getting that sort of square fall off. I mean, like, yeah, because it just looks really good now, and I feel like we would really be doing a disservice if we didn't at least try to get it perfect, because it's really good looking. And like, here's an example of playing the game with only one light source, and just, I mean, look at how good that looks, right? Like, the indirect lighting is just awesome. It's just so much better than what I'm used to seeing in a lot of cases. It just looks great. I mean, that's just amazing. And if we did move this to the GPU, it would look even better, because, like, don't forget, on the GPU, it's going to be, rather than, 8 samples, it's going to be like, it would be like 64 samples or something, we could do. So, it'd be, the quality level would be like that. So very little flicker as well, right? And that would just be like really, really, really hard to argue with at that point, right? So I don't know. I feel like we should do the rasterization just to see if it helps. If I knew for sure it would definitely fix it, I would say it's absolutely what we do. But there's a possibility that it simply won't fix it, and then we've done that work for no reason, right? But I mean, that's engine programming. Engine programming is about trying stuff and finding something that works. That's your job as an engine programmer. It's the game designer's job then to have this nice situation where everything just works, right? We build this for them so that they can go make a game. That's the whole point. We do the experimentation on the engine so that they can do experimentation on the game design, right? I mean, that's how that works. So I don't mind at all, but it is the case that, we may go do the rasterization and it doesn't matter, right? Like, it doesn't actually fix it. So anyway, I guess we just try it, and we see what we can do. If you look at what's going on here, it's pretty clear. So, like if I go and if you take a look at the light probe locations that are implicated by, this thing, what we would be looking at is basically a 5x5 square. Right. And the question would be, I mean, I guess I don't even really know that. Maybe it's only a 3x3 square. So, for a given light, it's going to be, we'd rasterize it into the 3x3. I mean, technically it's a stack because we would do both, it'd be the bottom and the top there. I'm going to hop out into an area where it's more pronounced and try to take a look at what's happening with the light probes, see if I can get a better feel for why why we're seeing that. And I gotta be honest with you, I don't, looking at this, I'm starting to think maybe interpolation really would be sort of more of it because those look about right. And I'm wondering, are we doing something wrong? Because even linear interpolation should not really be having such a hard edge. I mean, linear interpolation is capable of reproducing literally an exact circle. Linear interpolation just is not, does not really explain why we're getting that hard edge. So I'm a little nervous about this because I think we're seeing something else. I wonder if this has to do with mixing specular. Let's turn off the specular off because right now we have those both on, which is not necessarily great. So this material parameter, I'm going to turn it down to 0 so that it's only looking at the diffuse map. So that is kind of what I thought. So if you look at just the diffuse map, you actually don't quite have that same problem, do you? I mean, it still has more of a square aspect than you would like, but it's not nearly like the same as with the spec map where it's very hard-edged. right? That's the spec map. All right, so hold on a second here, folks. Everyone hold on a second. I'm going to look at debug draw octahedral values, and we're going to turn on the values, and we're going to use the spec atlas instead of the diffuse atlas so we can see what we actually have. I mean, no. Like, it still doesn't... Something just does not add up here. Something weird. Something feels off because when you look at what's happening with the actual light probes, you know, there's still a fair bit of light being collected by this. And maybe that's not really true because maybe what we're seeing there is... It really does feel like it. Maybe what we're seeing there is like, well, yeah, if you look like this, it is pretty smooth, right? So what you're seeing there is just the transition from a reflection vector that looks up into the part that does have the light source versus one that doesn't have the light source. You're just seeing that, you know, that difference. So that seems pretty weird. Let's go take a look at what we're doing there because I don't actually know. Well, I don't actually know what we're doing there. Let's be completely honest. We just don't know. So when we sample the lighting, which you can see us doing here, we pull out, you know, from the octahedral map a particular lighting sample and we merge them together. Here we've asked for just a specular so that we could look at it because the diffuse map is obviously a blur, a cosine weighted blur of the spec map, which is, you know, what you expect. So we sample the lighting each time, and we do it. We sample at each of the 8 the 8 corners of the voxel, you know, cage you would be in. And we use those to do a standard trilinear interpolation, right? Here's us lerping Z, you know, between the up and the down, basically. Using the Z, we then lerp the Y, and then finally the X, to produce the final result. That, you know, that's what you would expect to see. That's just a standard trilinear, right? Not a lot of anything particularly weird going on there. So it's hard to say that you know, that doesn't look particularly odd. Now, it's possible that there's some bugs in here, though, right? Like, you know, suppose we were computing Vox R wrong. You know what I mean? Like, that could lead to you having, you know, a harder, you know, fall off than you should. Light lookup voxel dimension -1 times vox UVW I can't say that makes a huge amount of sense to me. Like, why? Are we sending down the total dimension as being 1 less than it should be? I guess? Because that's a little weird. Right, that's not... I mean, am I the only one who thinks this is strange? Maybe I am, but... Like, what are we sending down for the vox inf total dim in the first place? What do we send down for vox inf total dim? This value. Voxel inf total dim. What does that get set to? I mean, someone must set that, right? So who? So it's in set light bounds. And it's here. So this feels a little sloppy. This is making me a little nervous. So this doesn't make sense exactly. I mean, it sort of does, don't get me wrong. But I think it's interpolating off by 0.5 in a way, right? I don't know what to make of that. So let's take a look at what this looks like with and without it. It's because it's really confusing, and I'm not sure how to process that. It's very odd, and I want to understand it better. So if I delete this, so that we don't have the -1, it should shift. We should see the lighting shift. Yeah, like that. And presumably it should be more wrong. Or otherwise I don't know why we had it shifted like that. Right? I mean, but why you would -1 that, I'm not quite sure. Because it's sort of like, it feels more, it feels like we're correcting for something that we did wrong in the first place. And so I'm not sure about that -1. I'm not sure I can justify that -1 very well. Now, granted, this has nothing to do with what we were actually looking at. I'm also not sure how us changing our orientation here should have any effect, because I thought we turned off the specular. Oh, no, we're looking entirely at specular. Never mind. So I don't love that. And I feel that's, I don't know, I really just kind of, that feels suspicious to me. And furthermore, so if you take a look, let's suppose I was correct that there should be a -1 there. Well, is there a -1 in here? Because these are the same code path, like one's on the GPU side and one's on the CPU side. And you can see here, like, we've got, like, all right, we're doing the same stuff. We do, like, an F chord and a B chord, right? That's this stuff right here. Inverse cell dimension times P minus total bounds, right? It's a very similar computation. In this case, we're trying to actually get a number that we index into, because this one's, in 0 to 1 land, and this one's in 0 to count. So that's why, it's a little bit different. So I mean, this is just getting the exact cell count. And so you would think this would too. I guess there is a difference in that the 0 to 1 UV scale thing is kind of messed up. The way that OpenGL does textures is really bizarre and strange. I mean, the way all 3D graphics cards do them, I've never understood it. It's very weird and unnatural. It's just kind of wrong. Like I think it's just objectively wrong the way they do texture lookups, personally. It's just, and it doesn't work with almost anything. Like, it's why they had to struggle so long with weird things. They tried to add, like, texture borders and all this other stuff. It's just wrong, the way that they decided to do texture mapping. So, maybe it could be that I'm not thinking through the weird, like, okay, 0 is actually, like, half a pixel back from the center of the first pixel, and 1 is actually half a pixel forward from the last, pixel. And if you actually internalize that, that's the extra one that you're removing when you do this, right? So maybe I could believe that. I'll let it go for now with just the to-do because, it doesn't have anything to do with what I'm looking at. I'm looking at the squariness. But, yeah, that was a bit disquieting as well. So I think you can also see when we look at the specular map, right? You can see that I can make the fall off either be hard or soft based on what the reflection angle is. And I guess that's just, that all that's doing is it's because you have that blur from the spec map to the diffuse map. The spec map just immediately falls off when you no longer are targeting the light source. The texels on that side won't have any contribution at all, right? So I guess what I'm trying to say is this whole thing might implicate the part of the code that I sort of said we would get rid of, but maybe we actually secretly need it, which is actually not so much better interpolation on the voxel, because maybe we don't really need that. Maybe our main problem is better interpolation in the octahedral map. I really don't want that to be true. Because it would be really nice if that wasn't the case. Well, okay. So here's what I'll say. Because I'm not really sure, maybe we just try some different things. Like, maybe we try a different interpolator. I've had multiple people write in asking for me to do this. And so, maybe now's a good time to say, let's experiment. Let's answer the question of, would an interpolator make any difference here anyway? And I think someone sent me one, and I've been delinquent in not trying it. I said I would try it, and I just haven't gotten around to it. So I will bring it up here, and I will mention it, and we'll see if it really helps, or not. And it was okay. So it was from Sebastian Mester. I'm sure I'm pronouncing that wrong because it's probably Sebastian Mestre or something like this. But they said, Hey Casey, I just looked at your most recent YouTube video. If you're looking at a different blending function for Handmade Heroes Ray Trace voxels, here's a cool one. And he says float F, float X, return X times 3 minus 2 times X. Float G is return FUV.U times FUV.V. And it says it's hat-shaped, continuous with a continuous derivative, and the forest samples always add up to 1. The derivatives are also 0 at the edges, which makes it really nice for blending light values at the far edges of the square. So it was probably hard for you to understand what I was reading exactly because I read some equations there that, probably were hard to see, but it's actually very simple. So let me just show you soy sauce. Let me just soy sauce this in here what he was suggesting so that you can see what I can see as well. So what they were saying is, I don't know what we're going to call this. We'll call this a mester in honor of the fellow who wrote in. So what he was saying was that, look, you pass in an x value and it returns x times 3 minus 2x. Right? So just like a cubic, right? And you know what? Since we were having a Desmos party today, there's no reason we can't Desmos this up, right? So if we put that in there, you can see that it's actually not that dissimilar to the lighting one, right? It's another one of these little sigmoid guys. And it just kind of goes like a little smoother up and then a little smoother out. So rather than just a harsh line, it's got like a little bend, right? Yeah, so that's the first part of it. But he had a second part, which he said that was when you actually look up the value, like where you're going to look up the value, I guess. So I think what he was saying is that when you actually do like the coordinates, you pass in the coordinates that you're going to look up, I guess. You know what? I don't really understand this part. I don't really understand this part. So here's another one that this is the other part of it, and I guess I'm just not sure where it comes from. So like here's the UV, and he said that we would do the first one. So basically, like doing this fall-off function on the U times the fall-off function on the V. And so I guess this is just a way to produce the interpolant in 2D. I'm not sure how that really helps us, though, because we're doing 3D. I don't really know. So I'm not sure how this was meant to be applied. Is, I guess, what I would say. You could do 3 of them. So, like, this. Right? So you could do that. But I don't know if that's really what the person intended. So, I guess I apologize. I probably should have asked some clarifying questions at the time. And so, yeah, maybe that's less good. So maybe this is not what they... So I apologize to the viewer because I don't actually know if this is what they were recommending. I assume this is for the lerp, preconditioning the lerp. But I really don't know. So we could try this and see, but it may not actually be what they were suggesting, so I apologize. So here is our Vox R. And so basically what we would be doing here is just, I think the intention of this would be, before we combine the values using trilinear, we would first precondition this value to sort of conform to that sigmoid function. And I think that's what they wanted, but honestly, I just don't really know. Oops, I've made a horrible error. Mester 3 must be broken. What did I screw up? Oh, wait, but that only gives you back one value. Yeah, now that, like this doesn't actually return a v3. So, how does that help you? Again, I don't really see... I don't really quite see how the blending's supposed to work. Because you need to be able to produce you need to be able to produce 3 blend coefficients, right? And I don't understand what this G value is. I could just call this on each dimension separately. But I just don't get what the UV part's for. Right? Because it's trilinear, so I need 3 linear interpolation values. I could feed each of them into the first mester. But the second mester, what would it be for? I just don't know where I would bother. Where would that go? Right? So, like, you know, this function, it's pretty easy for me to take this and just feed all of them into that. You know, that's the most straightforward thing to do. So, where we had the Vox R before, right? Right here, we would just say, like, okay, yeah, each of these... You know what I'm saying? So each of these we could feed through that interpolant. That's not hard, right? But I just don't see how that uses... I don't see how the second function gets used. I'm not sure. Oops. So that mester 2 and 3... These two... Or, well, the 3 he didn't say, but this 2, this one, I don't get. Right? So this is not going to be useful tests. I apologize. I guess I'll just need to get clarification on what was supposed to happen there. Because I don't know. I do not know what they wanted me to do. So I can do it to each of the axes independently, but what that other one was supposed to be, I don't know. So here's what that looks like. And you know, it's better. You can still see what it's doing, but it turns the squares into sort of rounder versions of themselves. I'll turn off the octahedral values so that you can see it a little bit better. And it's nicer, right? I mean, to be sure, it's definitely a little bit nicer. But I don't know that it really solves the problem. Like, it hides the problem, but I don't know, like, I still think there's some kind of core problem with the fact that we're not really capturing that lighting well enough. I don't know, maybe it's fine. I think it does help a little, but it's not quite right. So, yeah. I'm going to go ahead and turn back on our other lights also so I can see how that affected. You know, just if the interior is lit again, what does that look like? Just so we can get a better sense of it. I would say it doesn't really affect those lights in any particular way. Like, they don't look better or worse. They just look fine, either one. So I would say it's pretty low cost to keep this. If we didn't make any other improvements, we would probably want to keep it because it looks better than the alternative, I think. You know, I would say it probably does look better than the alternative. It's still not great, though. So yeah, I'm still not completely thrilled with that, and I kind of want to do a little bit of testing, I guess is what I would say. So I might do that. Now, yeah, so like in the chat, Frizio9 said, I still believe this might just be an artifact of too low voxel resolution, and what we see is actually expected given the current constraints. I'm pretty sure that is not true. So a linearly interpolated voxel can capture spherical fall off perfectly at any resolution. The only thing it can't do is capture the if two, it can't capture an interior curve. So if you're curving from like if you think of quartering a circle, if 2/4 of the circle have to happen inside the same voxel cell, it wouldn't, right? And so it's I think a problem not with the fact that we are using a voxel, and more a problem that just we are not producing the right function in our voxel. And let me try to substantiate that / debug this. So let's suppose that we take out the this sort of interpolant here, and go back to standard linear, which again I think looks great. Honestly, I think it looks good. And really, my only complaint is this sort of we're getting things are too blocky, you know, out here. Right. So what I would like to do is say, well, what would happen, just to sort of motivate this a little bit, what would happen if I literally just set the values in the voxel to be directly the fall off function from a point? And again, this is just me trying to kind of like convince you, and or for my debugging purposes, so that I can have a known function that I can put in there and validate, which again is also would be really handy, right? Let's make sure that that actually would look okay and look correct. And then you can also see it so that you know that I'm not lying, and or it doesn't work, and then I know we have a bug, because I'm quite certain that this works in math. Maybe not in our code. So let's suppose we go into the internal lighting core. If you look at what happens, right, we set up these work units, and they all go and do their little happy dance. And that happy dance is full cast, right? So full cast is the work function. What we do is we loop over all of the voxels assigned to a particular thread, and so like each thread takes an XZ cross section, right, of the atlas. Each thread does. Which, by the way, we probably have to fix to doing a more discrete partition than that, because if you had something that was more threads, they would not be able to effectively work on it. We probably need to split X up, because before we were assuming like, oh, well, okay, there's going to be a lot of these and blah, blah, blah. Now there's only really, like, there's only 2 sheets in Z. So yeah, maybe that is not the smartest thing. And maybe we should partition it so that we have like more, like Z is split for each one as well. So there's just more granularity there. Like, because, like, let's suppose you ran this on, like, a Threadripper or something. You know what I'm saying? Like, you're not going to get any acceleration because there aren't 64 different pieces to work on. So, so yeah. Yeah. So let's go ahead and take a look. And if I just go ahead, what I was going to do is to say, like, what if we just put in a hard-coded light value here? So instead of doing full cast, we just did something that wrote specifically to the octahedral map, like a thing that was a circular pattern. So we could verify that the fall off, was roughly correct, right? That we would reconstruct it properly. And what we could do is say, I mean, I'm not sure exactly how you'd want to do this. Like, do we want to just write them all into the same one? Like the transfer PPS value here. So what I'm saying is, like, look, we would say, okay, transfer PPS, so we're going to have to produce 8 values here. So maybe what we do is we just set them all the same thing temporarily. And then we set, this fall off func. This is what we're actually going to do here. We would lerp between, 0 and 1. I guess we don't really need to do that because we know we can just produce that value. So maybe the fall off func is just going to be fall off like 3 times, and then fall off is going to be like clamp 0, 1 some distance function, right? 1 minus some distance between. So I guess we just do length, the length of between some light location, which we'll just put at the origin for now. And we'll just say that it's going to be the length of the light location to wherever we're at. It's not the ray origin, it's the center of the thing. So it's whatever that light probe P. So that should be a radial fall off. What is the complaint compiler? I agree. That should not be a parentheses. So I guess what I would say is like that to me looks just wrong. So I think there's something else going on bad here, right? Because that should not really be the case. Of course, it's inside one, so maybe not. I don't know. We'll find out. We'll find out in a second. Okay, so I'm pretty sure that is completely wrong. That interpolation is broken. I'm pretty sure. And so if that's... Maybe I filled this out wrong, but if I did actually fill this out correctly, this would be why we're getting such squarey stuff, because it should not look anything like that. Well, okay, that's not actually true. So you have to do the subtraction. You do have to have a light floor in order for that to work. So I guess I would say, well, not exactly. So let me keep going on that front, because you do need to not have it ever hit actual zero. So you have to be able to do the floor. The thing that I removed before, you need to have. So in other words, right here, where we do this lerp, and we produce this light value at the end of it, we do have to basically drop this down further first. So, in other words, some value here that we agree on is our floor value has to be removed prior to the rest of the process, right? And we're going to have to clamp it as well. So that's going to be an issue. Like it's got to get clamped to 0, which... It's clamp 0 inf. Yeah, that's the one. Oops. Let's do it this way. Okay. So basically, like, after we sort of, do this whatever random fog thing, which we should probably just remove for now, because, if we were going to do fog, we would do it differently. And hey, look, there's our exact circle, which is what we would expect, right? Something's a bit odd about that, though. Like, I guess I'm not sure why it creates such a stark... is it because this is too much light to be removing? I don't actually know. Is it because the clamp 0 infinity is broken? What's happening there? I'm not really sure why that's happening, right? I will say that part was confusing. That was legit confusing. But here you can see that the proper reconstruction of a circle, once you remove a floor value from it so that the function doesn't get confused outside of there. I don't know what to expect if you were to remove a slight floor value prior to feeding it through that function in general. So that's... I don't know what that will do. So, yeah. And I don't know why there's no other lighting. Like, where is all the lighting? I don't know what's going on right now. Did I break something else when I was messing with that? Because if I take this out, of the equation, the rest of it should run the same, right? This was all I changed, I thought. What am I missing? What horror hath I inflicted upon thy world? Like, all I added literally just that, right? How is it possible? Is all of the lighting happening literally between 0 and 0.05? That doesn't seem possible. Is clamp 0 inf actually busted? Or am I misunderstanding something? I mean, that looks right. So is it just like... So let's suppose I said I subtract nothing. Don't subtract anything. All good? And now let's suppose I 100, like 1/100th of the total light value. What happens then? So subtracting only just that much is like where all of our light is. How about 1/1000th of the light? That is just crazy. It's crazy, right? Don't you think? How small that is? All right, so suppose we were to subtract a large amount. I'm just curious what this does to our interpolator. I mean, it's very circular, right? I mean, it is, right? So it does seem like it's a function reconstruction problem. Do you know what I'm saying? This is not specular, by the way, whoever said that in chat. This is just a diffuse map, right? At this point? Right. So we're only looking at diffuse. Specular would be this. That's specular. Right. So, gosh. I am... well, that both confirms and surprises me. It confirms what I was thinking before. But also it surprises me that so much of the light is down in the lower end of the range. So alrighty then. Well, anyway. So that confirms my suspicion, though, right? So if you look at what happens when you try to interpolate the linear function, you can see pretty clearly that where you get the square artifacts are where you lose the ability to interpolate because you no longer have a sample anymore of that function, the function that you were trying to reproduce. You don't have a sample of that function in the next cell over. The function has gone straight to 0. And so if you capture the light and you say, well, we're just going to use like a natural floor function that we remove out after we do the interpolation, you get your correct circles back. But the problem is you also get incorrect light levels. So how do you fix that? I say. Is the thing that I'm saying. So, I don't know. I mean, I don't really know how you would fix that. And, you know, if you crank it down to whatever level would be necessary to actually deal with the light levels as they are, it doesn't help you, right? So, like, this level of flooring doesn't do anything, right? Whereas this level of flooring does, but it removes so much light that it doesn't help you reproduce the circles that you want. I mean, you get nice circles, but you've removed so much light that you can't see anything. Although it is kind of a nice effect. It's not one we can really use. Is the ACS film function contributing to badness? No, not particularly. It's pretty neutral. You can actually see, like, okay, so that's what it looks like with the ACS film function. And oops, if I just remove it, you can watch the change. You know, and that's it. If anything, I'd say it's slightly better. Right? Let's go back. This is without it. And there's with it. You know, neither is great, but it seems like the ACS one's actually a little bit better. To me. So I don't know. I don't have a strong opinion about it. I would say this looks good enough probably now. With the film in there, I don't know. It's pretty reasonable. Like, I feel like you could ship this, and maybe what you do is you don't make a lot of regions that have this kind of feel to them, right? Like, don't do exactly this. Because you know, whenever you're in a region that actually has any kind of a lighting scheme at all, it looks totally good, right? Everything looks great. And, And even this area looks like okay. It's not great. It's only really the grasses that look pretty bad for whatever reason. They're, you know. We have hopped out of the game. So I guess what I will say is it does kind of answer the question of like, look, if you don't have the flooring, then linear interpolation is not going to cut it. Right? I mean, that's just kind of true. So I guess there's not a lot we can really do. Because, you know, would it be practical to up the voxel resolution? Yeah, I mean, I guess I don't know that we can really. It'll just make the square be small. I don't know that that's really going to help, but I mean, yeah, like we could, because maybe if we move this to the GPU, we can increase the voxel resolution to the point where it's fine. Yeah, I don't think that's a realistic option right now, but like with, you know, with moving it to the GPU, we would get a massive speed increase, or even just to a more modern CPU, we'd get a massive speed increase. We'd get like 4x or something moving to a Zen 3, right? So, you know, you could pretty easily double both your voxel dimensions for sure. So yeah, I mean, that's definitely true. So let's give that a shot, I guess. So the problem we're gonna have is that I don't actually remember how the voxel lookup dim stuff even really works. But so let's suppose that I double it here like so. And I think we might have to introduce a corresponding scale, because I don't know that we actually divide up. I think we actually just use, they're always placed. So that will just do a larger region, right? It's not going to actually, like, that's just going to produce a larger lighting region. Like, you can see that it's actually totally messed up, right? Like this part right now is going to be like indexing out of bounds, right? Because it's too large. So we would need like a way to shrink that down, and so the part that actually like starts the lighting, that would have to have that resolution. So this would have to be like a 0.5 thing. I don't know why that's producing a difference there. Why we're getting an out of bounds. I just have to look at that. Because I don't think we should. What is the spatial cell dim? 2 times the voxel cell dim. Atlas cell count is the spec atlas size. Yeah, so I think we should probably look at why I don't know why that's having a weird effect on anything. I guess technically that should be a 1.0 there, but yeah, we might have to switch into debug mode and find out what's the problem there. Like, what is going on here? In the grid build spatial partition, it's like, it's getting like an out of bounds lookup here for some reason, but I don't actually know why that would be happening. Doesn't make a lot of sense. Yeah, I'm not sure. That's a bit disquieting. So I don't know why that would happen. So let's take a quick look at why that is. Maybe it's something obvious that we should be thinking about. So I'm going to switch this to D, and I'm going to let it crash, and then I'm going to look at what's going on there. Because I would like to be able to change that resolution, even though I don't think we can afford it at the moment. Like, I agree that we should run that test, just so we have a better idea. So give this a second. To poot itself. It's gonna have to poot forth. Don't seem to be getting a lot of crashiness here. Probably just because it's not running fast enough. This is riveting. Okay. So we finally, after much waiting, get to the part that we were looking for here, which is in flat indexed from. And the index that it's asking for is out of bounds of the grid. So, the grid has a cell count 30, 22, 1. And, it's asking for 18, 9, 1. And, that is, it's the Z value there that's actually incorrect. So not sure I know what's going on there, because I would have expected it to be another one of the I guess, yeah, I wouldn't expect the Z to ever be a problem. And in fact, when we were doing these insertions, since there are not multiple levels of Z, the min-max node here, this part, it doesn't, I don't even know why we're getting that happening in the first place. The spatial grid itself, when it does get indexed for P, yeah, like, I guess our Z is just not clamp to the correct amount. We can fix that pretty easily by just removing this iterator, because we don't allow there to be multiple z's anyway, so the z is always 0, and we don't actually need to loop over it. And I guess the reason that we were having this problem is because the get index for p, it's just on the outside of where those bounds should be. So I guess changing the resolution, I don't know why that would actually cause that problem, though, because we're not changing the z part of this, so it is a little bit concerning. But I guess I will say that, we probably should simplify this, because we did remove z, so we don't have, there isn't multiple z now. It's literally just that. So that entire thing should never be a problem. But, I don't really know. We didn't optimize this code path for the non-z case that we ended up switching to, where, the spatial index for z is just always going to be 0, no matter what happens in this case, right? Same with this. So let me take a quick look and just make sure that all of these things, we even had an assert in there for it. And I don't know what's going on there. I guess the problem is somehow our z bounds are not as high as they should be. I'm not sure exactly what was going on with that. Let's see if this fixes it, because I don't really want to investigate that right now. But, again, we took z out of everything, and we did it pretty quickly, so we probably don't quite have it right. But I don't know. This may not be enough to fix it. Let's let it freak out again with the stupid glove. So I would say it definitely looks better, right? I mean, I could convince myself that that was better. You do see the sampling error more, right? You can see the shining. It's interesting. So let's take a look. And if we increase that one more time. We've got that's going to be too dense for it. Because remember, we're sending down floats for these things. So, it's not... Yeah, you're not wrong. It definitely does improve the situation. So maybe it is just not sufficient sampling levels for what we need. And if that's the case, then I guess we're just kind of screwed. Use bigger light sources is pretty much your only option at that point. So I don't know. I do not know. Yeah, bigger and slightly weaker light source, right? Um, all right, well, I don't know. I'm not feeling particularly inspired today, so I can't say that I have any really great ideas about what we would do after this. It's not quite as good as I would like, but it's also still pretty good. We could just try, like, playing to the strengths of the system and, using light sources that are going to be, like, larger than what we're currently making. That's certainly one option. Like here, we've got these are, maybe we update these to be more like larger lights, maybe like 0.7 or whatever, and then we drop the brightness down. And maybe that's fine. I don't know. Because again, like we can make the light itself, the thing itself, be bright. And so maybe we just use larger light sources and we call it a day. Because I don't know how squarey those would look. Like I don't know. It's still a bit squarey. But it's not that bad. Like I can live with that. And we do have the ability to change the interpolator again. I'm not sure we want to, but we do have the ability to change it, and we don't really know. Also to try other interpolators. But I don't really think that's going to solve our problem, to be completely honest with you. I don't know any amount of interpolation is really going to fix that. I mean, maybe it does. I don't know. Like, it still just kind of looks like it looks. It just looks a little bit more radial, but oh well. So I don't know. So maybe you just have to make sure. Maybe there's like a certain Nyquist. Maybe we try to like move it to the GPU and get, and make it go faster so that we can have a denser sampling. I don't know, right? I don't know. Is it trivial to move to the GPU? I mean, yes and no. It's trivial in the sense that there's no it'd be like the exact same logic basically. It's very, very time consuming and annoying because programming sucks. Like the way that these things are written has to be completely different, and the GPUs suck to program in general because the environment for debugging is super lousy. So yeah. So maybe, I mean, let's put it this way. Looking at this, you might say that like you could believe if you just cranked up the actual like resolution that maybe that's enough, but I don't know. I mean, it still also kind of looks very squarey. In here it doesn't, and I think part of that is just, again, when you get out here, the reason is there's nothing else. You're only seeing just that fall off, right? Because there's basically no bounce lighting. There's no nothing there, right? Whereas everywhere else, you get more. There's more that's filling it in, and So I don't know. What is the right solution to this problem? So let's ask a question. Let's ask the following question. Suppose we were to increase the power of the light source. Right. So let's say that I increase the power of this light source to a very high level. It's at 5 now or something, right? Again, I'm just trying to think about how you would go about fixing this problem. So suppose we change this so that the lights are larger, than they should be or whatever, and they're super powerful. Like, here's my blown out light source gonna come get you. And then I remove the light floor from the very powerful light. So, we're gonna try the light floor removal trick again. So I say, like, okay, clamp 0 inf, surface reflect RGB minus V3, and it's like gonna remove, some amount. I don't remember how much we need to remove. Oops. I forgot the semicolon. The entire world crashed because I forgot the semicolon. Isn't that the programming way? Not in Python, it's not. So, right, like you can kind of see now that if you just increase the power of the light source, you can still get that same trick. And now it looks right. I feel like there's a way to do this. I feel like there's a way to do this, and I just don't quite understand it enough to do it. Hold on a second. Let's change the way we're writing this, just so it's a little easier to see. So we're 100 timesing our light, and then that would mean you just subtract 1 from it for now. Okay. And here's us in our room doing stuff, right? Then we go and say, okay, we want the fall off to be smoother to 0, though, right? So when we subtract the 1 away, well, I guess I'm not sure exactly why that produces. I'm still not quite sure why it produces exactly what we're seeing now. So that is a little bit tough. But let's say I 10x these lights. So they're in the mix again. I feel like I don't understand quite why we are getting... So I'm doing something wrong. We shouldn't actually be getting what I'm seeing right now. After the flooring trick. It's... doesn't quite make sense to me why that would be happening. I'm a little bit confused as to why that would be happening. Oops. I'm going to power these lights up even more. I'm going to make these full bright. So I just want to see what's going on because I don't quite understand it. Yeah, something's a little bit off about this. Because all that should be happening is things should be getting a little bit dimmer as you turn that number up. But that's not really what's happening, right? What if we tried to, like, I wonder to what extent this would work if we just try to sort of clamp, well, I guess it's not really going to work. But I'm just saying, like, I wonder if there's a way to really, like, sort of smooth out that transition region differently than what we're doing. So, all right, so let's not do that. And... we'll go back to what I was doing before. All right. So if we don't subtract 1, I guess I didn't need to restart it, but I did. If we don't subtract 1, here's our world. Everything looks hunky-dory. But we have our blockiness problem. It's a little too blocky. So if I go in here and, like, what happens if I just say, what happens if I square the light value? More blocky, less blocky. Like, way less blocky. Not very much light, but way less blocky. Right? And I guess I would say it's for exactly that reason, right? Because now a lot of that tail, the low values in the tail are now, you can't see where they actually hit their 0. They're spread out further. You know what I'm saying? So I wonder if there's something we can do. So let's go back to our Desmos here. I wonder if there's something we could do where we would be kind of flattening that bottom part more heavily. So, like, if we were to take this thing and is that right? All right. So, is that undo? Yeah. So, yeah. I'm thinking, what if we did more like that? Right? And now we would need to kind of adjust potentially the rest of this thing, although maybe not. So what's B normally? VSO3. So what if we just said, no, B is 0? What happens then? More blocky, less blocky. Kind of hard to say. Not really that big of a difference either way, I guess one would argue. So we may want to play with that value as well. Let's zoom on in there again. I really wish it didn't. I really, really wish it did not reset the view. That makes it really hard to compare, right? So Z at 0.5. I don't know. Still not really good enough. Oh, I did type 0.5. Oh, whoops. Okay, hold on a second. Yeah, let me take a look at that really quickly. But I don't think this is gonna work. Like, it's not quite a winning strategy. You know what I'm saying? Like, it's pretty good. It's pretty good. It's just not quite a winning strategy. It's not quite a winning strategy. So I don't know. I don't know. We may have to perk on this. And like I said, maybe we just go forward with this and say, look, we know roughly, like, this is basically like what the game will then look like, right? Like this is good enough that we can, maybe add like a glow pass on there, and then you're basically like, that's it, right? That's what the game looks like. And, the squariness is not maybe fabulous, but you just say, look, it won't really change the look of the game. It'll just improve the quality if later we try doing something where maybe we do it on the GPU and do a denser sampling or something, right? And so maybe we just call it a day and say, okay, we can go ahead and pull the 3D out of the collision detector, and then, put in some of the gameplay rooms and just see, assuming that they all look fine in this, we just say, look, if the quality improves later, it improves, but we don't, like, we know what it looks like now. The lighting, you can have all of the game design rooms can just assume that the lighting looks basically like this, and if the quality improves from here, it shouldn't, like, materially change everything in the design, right? Like, it shouldn't, like, break anything at that point, I don't think. So I would say, like, yeah, we just add some bloom, because we need that, like, add self-illumination and bloom to our pass, because right now, I don't even know how that's specified. I think we had something random in there for it, but it's, like, not, I don't really remember exactly how. Like, that's how these things, it's how this stuff is showing up right now, kind of like a bad self-illumination thing that's happening. So I know we've got something in there that's getting passed down, but we should go clean that up and make sure we're passing down something sane. And then the other thing we should probably do is send these things down as 16-bit or something. We are sending these down as full float right now for no reason at all. And that doesn't need to be happening either, I suppose, but, so. All right. So let's call it a day. I think that's good enough for now. We'll have to think a bit. We'll have to think about what we want to do, and maybe the answer is, like, look, for any further quality, we're just going to go ahead and do this on the GPU and try to sample the voxel more densely, and that's how that's going to improve the, the look or whatever else, is supposed to happen there. I also don't know. I assume that the spheres doesn't help here either. I don't think we tried it with the latest version necessarily, but with the spheres, I don't think it would change anything, but we should double check to make sure that it wouldn't, because I don't actually know. I don't see any really material difference there. Looks about the same. It also really looks, the other thing too is at 8 samples, it actually also looks great as long as you're in an area with some reasonable amount of light. So you really only need the 16 samples when you're in an area like this where it's higher, and even then you can get away with it. So I may leave it at 8 for now as well, and we'll go from there. All right, I'm happy with this. I'm happy to call this the lighting that we'll use for now. Yeah, I'm happy with that. We can just make that be that. I don't think we have to go any further than that for now. All right, good work, team. I can still punch through walls. We'll be fixing that in a moment, but all right. All right, I'm going to call that a day. I think we're good. Next time we'll just add bloom, I think is what we'll do. And then we'll just say that's as good as it's going to get till we basically ship. Like, you know, maybe we put this on the GPU way go back to yeah, the frame rate's a little too high. Okay, fair enough. But I think that's it. So we're gonna call it. That's just where it's at. So thank you everyone for joining me. It's been a pleasure coding with you always. I think the lighting looks fantastic. Unfortunately, we do have that blockiness problem. Nothing's perfect. And I guess what I would say is we can probably just lean on the GPU to solve that for us in the future. We can probably just say, you know what? If you want really amazing circularness on your lights, then go buy an NVIDIA RTX if you can actually find one. Steal one from the cryptocurrency miner next door. And, you know, we'll do a GPU pass at the end where we just put the lighting on the GPU side and go buy more hardware if you want to look cleaner, right? So yeah. So there you go. We did an RTX on comparison. Yeah, exactly. All right. Thanks everyone for joining me. I'll be back here next week. Maybe we'll do the bloom, and then we'll just call the lighting kind of shelved for now and move on to cleaning up some of the other stuff. Probably to get the room gen going, try to generate some stuff like room gen and collision detection so that we can kind of just like play through some rooms. And get the lighting. I want the lighting to work nicely with like the gameplay down there. So just try to make that stuff make some more sense. So we'll get that going. That's it for today. Until next time, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.